ape or something like that. So it was like breeding when they have like big machines and kind of weird media to store data. So it's not one of the well-known things that you would use to actually generate pseudo-random number for cryptographic purposes. The other thing that we wanted to say is that it leads to remote code execution. If Microsoft accepts that with SMB relay or SMB credential reflection, you have to accept that in this case. Like I said, one thing to remember that is something that is well known or that is known inside the security community is that a PRNG is not the same thing as a cryptographically secure PRNG. For example, like I said, LCGs are not supposed to be used in cryptography. They are only supposed to be used for statistical purposes. And the other thing is that since this is a flow that has been in the code for so long, I mean, I think that perhaps when you are, things that you have to, I think, keep in mind when you are reviewing such code that is generating random or pseudo-random numbers or that are implementing protocols similar to this one, is that if you are auditing the code and you see a call to blah, 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 random, blah, 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 don't expect that function to return the kind of random that you need. You actually have to go into the function and analyze what the function is doing. Don't ever assume that because they are calling random, even if it is a function provided by the operating system, because RTL random actually is exported by ADBA API 32, I think. I don't remember. I might be wrong, but it is exported as an API that a user can use, and it's also used in the kernel for some other things that have nothing to do with cryptography, but take care of, I mean, look for that. Be careful with that. And the other thing also that I kind of said when I answered his question is verify how the entropy is gathered. In this case, the entropy was gathered using the current system time and adding a global variable. And that's not a good way to do it. I can't explain how to do it because it's very long to explain that. But go get a book about cryptography and read about that. And also, it's very important how the seed is created and how it's used. For example, like I said, it's not good to take 2 bytes and then expand those 2 bytes to 4 bytes because you actually do not have 4 bytes of entropy. You actually have only 2. So that might be a wrong use of a seed. And finally, you have to look for what is called side channel attacks. Side channel attack is basically, in this case, is that the server is giving us the current system that is using as the seed or to generate the seed. That is called a side channel attack because the server is leaking some information to the attacker that the attacker can use to guess or set the internal state of the PRNG. So you also have to look for those things when assessing or auditing this kind of code. And that's basically it. So if you have any more questions? No, that's it? Yes?
After the patch was released, have you effectively checked how it works against the patch?
How it works now?
No, just asking after the patch was released.
How it works what?
Did you check the patch?
Ah, yes. No comment, I don't know. No, I'm kidding. No, we just check it briefly. It appears to be, I don't know. No, it's different. We don't know. It appears to be doing something much better. That all the tests that we did, the patch passed those tests, so it appears to be okay. But I mean, as a security consultant, I don't want to say that it's okay because I haven't analyzed it. But it appears to be doing its job correctly. But we haven't spent too much time looking at it, so I don't have like a final answer about that. That's it? Right. Thank you very much for your time. Bye-bye.